Alright, so in this problem, we have two professors and their grade distributions are shown, and we want to figure out, is there a difference or is there evidence that one of them is easier greater than the other? Okay, so in this case, we're going to test the hypothesis for homogeneity. So our parameter here is the distribution of grades for Professor A and Professor B. The null hypothesis, H, the null, is the distribution, or actually, yeah, I'm just going to put the grade distribution. Is the same for Professor A and Professor B. Okay, the alternative hypothesis, obviously, is the grade distribution is different for Professor A and Professor B. Okay, the assumptions and conditions. The data is counted data, so data is in counts. It doesn't say that this is random, so we'll assume that this distribution is representative. And then we got to check the ECFs, right? So let's check the ECF deal. So to do for A's Professor A, we're going to do Professor A gives 40 grades, so there's 40 students he has out of 72 total students, and then there were 12 total A's. So we're going to do 40 out of 72 times 12. So his expected was 6.67. And then 40 out of 72 times 23 B's, and there's 12.78. And then 40 out of 72 times 22 C's, 12.22. And then 40 out of 72 times 11 D's, 6.11. And then 40 out of 72 times 4 F's, and we got 2.22. Okay, so we already have a problem. Okay, now Professor Beta's deal, he's going to have 5.33, and then he's going to have 10.22. You would do the same thing. You just do 32 out of 72 times all these row totals. 9.78. And then 4.89, so he's less than 5 there, though close, 1.78. Okay, so we don't meet the ECF. We got a problem here. We have a problem, though, just below there, and we have a problem here. So what I'm going to do is I'm going to combine these two categories. So I'm not going to have A's, B's, C's, D's, F's a separate category. I'm going to have D's and F's as one category. So here's what we're going to wind up doing. So all you do is you just add these expected values, and for you would get 8.33 D's or F's, and then if you add these two, you would get 6.67 expected D's or F's for Professor B. So if we do that, we're good to go. Our ECFs are all at least 5. Name the test. This is a chi-squared test for homogeneity. Test statistics, we already got the ECF, so now I have 4 rows. So the 2 degrees of freedom, 4 minus 1 is 3, and I have 2 columns, so 2 minus 1 is 1, and my degrees of freedom is 3. Obtain P. Again, chi-squared is the observed for A's minus the expected squared over over the expected, and I'm just going to go all the way to the D's or F's for Professor B, and he had 3 minus 6.67 quantity squared over 6.67. Okay, and now we got to put all this into our calculator. So we're going to go to matrix, and we're going to go to edit matrix A, and my matrix is now a 4-row by 2-column matrix. So I'm going to put 4 by 2 in, and then I just had to put in all of the observed values. Okay, and we're going to go to stat test chi-squared test, and then observed as an A, put the expected in B and draw that out. So that's what it's going to look like. So we got a p-value of around 0.0255 and a chi-squared value of 9.31. Okay, so I'm going to put down that this equals 9.31. I'm going to draw this up. So this looks like this. Chi-squared equals 9.31. Big P equals 0.0255. Make a decision. We would reject at the 0.05 level. And then I got to start, now that I rejected, I got to go back and look what happened. Well, Professor A definitely gave more A's and B's than expected and less D's or F's. He gave less A's or B's than expected and more D's or F's than expected. Professor B, he gave more A's and B's than expected and had less kids fail than expected. So that's what we're going to put down. Okay, so Professor A, just looking at this now, I'll write it here. So my conclusion was there is evidence that the grade distributions are not the same for Professor A and Professor B. Okay, Professor A had less A's and B's and more D's or F's than expected. So Professor B had more A's and B's and less D's or F's than expected. Now, do not put down that Professor A is an easier grader or Professor B is an easier grader. You don't know that. Okay, it could have been the makeup of the classroom. Maybe Professor A had kids that didn't want to work as hard. And Professor B had a bunch of kids that really were either like really smart or they went in the library and did a lot of work out of class. So you don't know that. So you can't come up with the conclusion that one of them is an easier grader than the other. All that you know is the grade distributions are not the same. Okay, so that's basically where we would leave it.